Today we have solved one problem. Determine charge entering a terminal between t that is equal to 2 seconds and t that is equal to 4 seconds. If the current through the terminals is defined by the function I that is equal to t square minus 2t plus 1 ampere. Actually, what are the values given in that particular problem? In this particular problem, we want to determine the charge entering a terminal. Okay, how much charge will be entered? The time durations will be given from t that is equal to 2 seconds to 4 seconds. The current to the through the terminal, not give exact value, they given in the form of function. Okay, so I that is equal to t square minus 2t plus 1 ampere. Now we can solve that problem. So we know that q that is equal to integral of I into dt, lower part 2 and upper part 4. We can substitute all the value. I, we know the function they given. Right. Okay. So I think now you clear better. Yes. Q that is equal to I, we know the value of t square minus 2t plus 1 into dt. We can get inside what happened. After the integrations, we get the solutions. T square will be become t cube divided by 3. 2t become 2t square divided by 2. So 2 get cancelled. So remaining t square available. dt into 1 dt, integrator dt, we get t. So the upper part 4 and lower part, lower value. Upper value 4, lower value 2. We can substitute first of all upper value minus substitute the lower value instead of t. After we get the simplifications, the answer is 8.66. We can round off 8.667 coulomb. This much of charge entering from 2 to 4 seconds, right? Next, we discuss about voltage. Actually, the definition of voltage, we can say voltage or electromotive force or potential difference. Okay, both are same. So the potential difference between 2 points A and B, the energy needed to move a unit charge from point A to B. Okay, actually we studied in lower class physics. Okay, from consider one unit of charge from one point to another point, we give some the force, that is a potential difference. Otherwise, that is called as voltage or electromotive force. Now consider the point named by A and B itself. So the potential difference between the points A to B that indicated VAB, that will be equal to dW by dQ. How much work will be done depend upon the charge. That is called as voltage. Okay, actually, I give the statement now. The statement will be in the form of equation. VAB that is equal to dW with respect to dQ. That means what happened? The work done will be happen. the work process differentiation, okay, with respect to charge. Charge from where to where? One point to another point. At that time, what happened? Energy will be consumed or energy will be spent. We spend, that means it consume or it utilize some energy. That is a potential difference between the 2 points. That's a potential difference or voltage. So unit of voltage will be marked by volt V. So 1 volt, that is equal to 1 joules per coulomb. That will be equal to 1 Newton meter per coulomb. We can see the conventions. Okay, look at that. Suppose there is no point, means we can simply say positive negative terminal. Suppose two points there, means we can indicate A considers positive charge A and negative charge B, right? Look at that. This is basic, very, very important, because the arrow, okay, the current directions is very, very important. Uh, in future, we solved about network theory. Okay, next semester, network theory also there. Uh, in this semester also, we studied about simplification, network problems. So the current directions inside, in the sense energy consumed. Clear? Inside in the sense energy consumed. So energy consumed by the circuit elements, the arrow will be downward direction. That means from positive to negative. That is a meaning. Okay, from positive to negative. Suppose the current directions will be, okay, wherever the positive charge to negative charge current directions means positive to negative, in the sense energy consumption happened. Suppose it away from the element, or the arrow indicates like that. Negative to positive means it delivers, okay, the energy is delivered to the circuit element. That indicates like that. Okay. Are you able to see? I think it is little bit. Okay. Can you, are you able to see? Right. Next we can compare with the mechanical energy. Okay. Consider one vehicle, okay, that will be moved from 1 meter distance. So 1 Newton mechanical work done, right? That is equivalence. The electrical work is equivalence to mechanical work. Then simply we can say mechanical energy equal to electrical energy, right? One voltage source are there. Now the current directions, what happened? Positive to negative. Okay, positive to negative, na? Yes or no? Positive to negative to the load, in the sense positive to negative means energy consumption. Okay, energy consumption. Remaining energies are there, na? The remaining energy will be, the current directions will be give that negative to positive. Now what happened? It delivers. Okay, remaining energy will be going to the voltage source. That's the meaning, right? So this is a basic thing. So mechanical work, that will be equal to 1 joule. Electrical energy, that will be equal to 1 joule. So both we can say that's a equals. Right? Both the mechanical energy or mechanical work will be equal to electrical work or electrical energy. Clear? Next, we studied about the definition. 1 joule per second. 1 joule per second that will be equal to 1 watt. Okay. Spends 1 joule within 1 second. Okay. How much energy spent? 1 joule within 1 second. That is a meaning. So 1 joule that is equal to 1 watt second. 1 horsepower that will be equal to 746 watts. Clear? So 1 joule per second that is equal to 1 watt. 1 joule per second that is equal to 1 watt. Both are equal. Next, power, electrical power definitions. The product of voltage into current. It will be indicated in the slide. Na? So how much voltage required to move the charge? So the wave of flow of electrons, that is current. So we cannot separate it. Okay. Suppose one charge move from one point to another point, we give some energy. Okay. From one point to another point. Na? Example, 1 coulomb charge. So voltage also, that means potential difference also there. The charge now what happened? Move from the flow of electrons. So current, we cannot separate it. So power that is equal to voltage into current. Clear? Yes, we can move next slide. So power is the rate of which work being done. Power is the rate at which the work is being done. Power that is equal to dW divided by dt. We can write in the form of dq. Okay, dW by dq into dq divided by dt. Actually, we know that dW by dq voltage, dq divided by dt, that is equal to current. So voltage into I. So what is the unit of power? Unit of power is nothing but joules per second, or otherwise we can say watts. So energy delivered to an element between T1 and T2. Okay, that will be indicated like that. Integral of T1 to T2, P into P down. So we can substitute that. After that, we can get VI. What is the value? What is the meaning of that? W, we get final integral. We can get W T2 minus W T1. Upper part minus lower part, right? So here the diagram also important. So in a circuit, total circuit, the summation of all the power must become zero. It's an interesting factor according to the energy conservation law. How much energy will be delivered and the same amount of energy will be consumed by the whole the circuit. So there is no power. That's a meaning. Okay, okay, we can study deeply in further more classes. Now you can just know about that. So the summation of power in a circuit must be zero, right? So how in previous slide we see that voltage. Okay. So here also the element is consuming power. Consuming power in the sense of positive. The element which is consuming power positive. Suppose the element is delivering power, it's negative. Right? So consuming in the sense P that is equal to VI. Delivering the power in the sense of minus VI. Right? So positive sign convention when the current through the element in the direction of the reference voltage drop across the element, a positive should be used in expression relating to the voltage to the current. The standard of fixed power of tens already we know that in a lower classes, so there is no need to mug up and your calculator, your backside of the calculator. So there. So it already studied in lower class. So next, electrical energy definition: 1 kilowatt in the sense of 1000 watts. 1 kilowatt in the sense of 1000 watts. 1 hour, that is equal to 3600 seconds. Okay. So energy, that is equal to power into time. So kilowatt hour, power into time, kilowatt hour. Okay. So we know that power value, how much? 1000. Time value, 3600. We can multiply 3,600,000. Okay. 3,600,000 joules. That's a energy. 1 kilowatt power in the sense of 3,600,000. Okay. 3 million. That means 3 lakh 600 and sorry, not a 3 lakh 3 million. Okay. Yes, million. Lakhs also right. Yes. That means 36. Right, like that. Okay. So calculate the monthly payment for energy consumed by the lamp shown in organ side. One socket also there. Can you see that? Yes, now you can see. So source of voltage 220 volt. Current drawn by the lamp is 5 ampere. Price of electrical energy is 12 cents per kilowatt hour. Actually, here mentioned for globalized subject now, that's why I used cents per kilowatt. Okay. So power, we know that voltage into current. So we know the value of voltage 220, current we know that 5. So 1100 watts. So energy, that is equal to power into del T. So 1100 watts into 24 hours day into 30 days per month. So that will be like that. 792,000 watts per hour. That means 792 kilowatts hour. So monthly payment, how much per unit? 12 cents now. So 792 into 12 cents per month. So 95.04 USD dollar. That means per month. Next, a stove draws a 15 ampere when connected to 120 volt line. How long does it takes to consume 30 kilojoule? So we know the value of power V into I. That means V how much? 120 volt. Current 15 amperes. So 1800 watts. So we can conclude in kilowatt. So 1.8 kilowatt. Time we know that energy per power. So like given how long does it take consume 30 kilojoule now? So we can put the energy value instead of 30 kilojoule and power 1.8 kilowatts. So finally we get 16.66. We can round up 16.667. So third problem, a notebook computer has a total power consumption of 70 watts when running an average applications. The battery used in the notebook has a capacity of 300 watt hour. What is the average battery life of this notebook? So time, we know that battery capacity with respect to power. Battery capacity how much? 300 watt hour per hour. Power how much? 70 watts. So 4.3 hours. So how watt hour is sometimes used in the unit of energy instead of joules. This much is enough for today. If you have any doubt